Hello and welcome to Train Signal. You're watching video number 10, Linux File System and Storage Management, part of Fast Track CBT Video, Linux Networking and Administration. This is our table of contents for this video. I know it doesn't look very long, but actually there is a lot of in-depth information in this video. So first we're going to talk about Linux file systems, then managing storage devices and file systems, and storage commands and configuration files. So let's get started. First off, I want to point out that this video covers 3 Linux Plus objectives. They are Objective 2.1, Manage local storage devices and file systems, using CLI commands, for example fsck, fdisk, and mkfs, or make file system. Then it covers Objective 2.2, Mount and unmount varied file systems, example Samba and NFS, using CLI commands. And finally, configure files that are used to mount drives or partitions, for example fstab, mtab, Samba, NFS, and the various syntax that goes along with that. Now let's get started with our material. So first off, I want to point out that Linux does not have drive letters as in Windows. There is no C drive, D drive, E drive, F drive. Linux doesn't work that way. With Linux, storage devices are mounted on a directory within the normal Linux directory structure. So at the root of the Linux directory structure you have the slash, or the root directory. Everything in Linux is mounted on top of that. So if you want to create a new partition and a file system and mount it on there and call it David, you would have to create a directory called David and mount that file system in there. So let's go a little bit more in depth into that. For example, say you wanted to mount a CD, a physical CD drive. It might be mounted on the /media directory. That's created there by default just for mounting things like CDs. So let's move on to the next slide. So I want to point out that there are many types of storage devices, and Linux has names for them all. So we said the storage device has to be mounted inside the Linux directory tree. Well, there's a lot of different types of storage devices. So the first one is ATA hard disk, type of hard disk. These ATA hard drives would be called dev/HD and then X, where X would be a letter. So, for example, the master disk on the first controller is dev/HDA. So if you have ATA drives, that's what it looks like. Dev/HDA would be your first disk. Now if you have SCSI devices, like hard drives, they would be mounted on /dev/SD for SCSI disk, and then X. So X represents a letter like /dev/SDA or SCSI disk A. And then if you have serial ATA or SATA devices, these are sometimes treated like ATA and sometimes treated like SCSI. So it depends on which driver you use. If you use a SCSI driver or an ATA driver, that's going to tell you what the name of the device will be. Will it be dev/HD or will it be dev/SD? Now disks, you've got these disks, and you've got them on your system, and they're called dev, SD, whatever. These disks are further broken into partitions. For example, dev/HDA3 is a partition on dev/HDA. So within one disk you can have multiple partitions. So these are just chunks of disks broken out for a certain purpose, and then they're given a name or a number, in this case dev/HDA3. Now partitions are logical disks carved out from physical disks. That's the technical definition. These pieces of disks are used for certain purposes. Linux typically uses the PC partitioning system made up of 3 partition types. They are primary partition, extended partition, and logical partition. So an extended partition serves as a placeholder for a logical partition. And a logical partition, of course, resides in an extended partition. So in the PC-based operating systems like Windows, you can only have one primary partition, then you have an extended partition, and inside the extended partitions are logical partitions. But to Linux, these partitions typically don't mean a lot. Primary and extended partitions are numbered 1 through 4, such as dev HDA1, and logical partitions start at 5 and go up. Now, any floppy disk in Linux is called dev FD0, and it's going to go up from there if you have more than one. You may also have special disks like dev FD0 U1440. This weird name at the end of it tells Linux that this is a 1.44 megabyte floppy drive because there's different types of floppy drives. And this works the same way with tape drives. For example, the default tape drive in Linux is /dev/MT0 or magtape0, magnetic tape 0. Now, on the end of that MT0, you can have other weird extensions that tell the tape drive to do special things, like use a different higher density cartridge or lower density, or don't rewind the tape when you're done, or there's different extensions that you put on the end of that. Now, ATA CD-ROM drives are called dev HDX, whereas SCSI CD-ROM drives are called dev SCD or SCSI CDX. And these are letters too, A, B, C, D, whatever. However, Linux creates a link to the /CD-ROM drive or CD-ROM directory for a CD-ROM drive. To create new partitions, you use the fdisk tool. So fdisk is used to create new partitions. Just like in Windows or in DOS, you're using the fdisk program to create new partitions. There is a GUI Fedora Volume Manager program, kind of like Disk Manager in Windows, and it's called LVM, Logical Volume Manager. It can be used to perform many disk functions. Now, you can also use a few other programs such as Parted. This program is installed by default in Linux. It's very similar to fdisk. It's command line based, it's difficult to use, and it has its own little eccentricities, but it's there as well as fdisk. You can buy Partition Magic. This is a commercial program that you have to pay for. Very nice program, but you do have to pay for it. A free program that's very nice and graphical, just like Partition Magic, Qt Parted is graphical, and you can download it for free. Now, once you have a partition, you must create a file system on it. A file system is defined as a low-level data structure used to organize files on a hard disk partition. Types of file systems are ext3, riser, and fat. For example, NTFS in Windows is a type of file system, but it's not used in Linux. Now, to create file systems, you use the mkfs command, or make file system. The FSCK program is used to check the integrity of file systems. It can find corruption and fix it. So these file systems sometimes can get corrupted. It's possible, even though ext3 is a journaling file system and it's most commonly used in Linux, the possibility exists that it does get corrupted, and if so, you use FSCK to find that corruption and fix it. Now, the etcfs tab file is used to tell Linux what file systems to mount when the system boots up. So we'll look at the etcfs tab here in just a minute. It has its own little format, and different columns mean different things. But in general, you're telling it what partition and what file system is on that partition and where to mount it. So the fs tab tells Linux what file systems to mount when the system boots. Now, the etcm tab file is the list of file systems that are actually mounted. So these won't always be the same if there's a file system that's not mounted. If all file systems are mounted, then these two files should be the same. Now, you can actually mount and unmount file systems yourself using the mount and the umount command. Note that to unmount file systems, you type umount, not unmount. There's a big difference, and I have struggled years ago trying to type unmount when the command's actually umount. Now, file systems are mounted on mount points. Mount points are simply directories. So I could create a directory on the root file system called /phishing, and then I could create a file system and I could mount the new file system on top of that directory. So these directories are usually empty directories, and then the file system is mounted on top of it, and it magically appears that it's on the same disk drive. It could be on the same disk drive, but it might not be. But it's definitely not on the same partition on the same disk drive as the root file system that it's usually mounted on. Now you can have things mounted on top of other things. And what I mean by that is, like, you could have a file system, of course you start with root, the / file system. You could have on top of that the user file system mounted. Then you could create a directory inside the user file system called phishing2 and mount a file system on that. And then inside that file system you could create another directory and mount a file system on that. Now these directories, I said they're usually empty. They should be empty, because what happens if you have something in there and you mount it on top of that directory, whatever was in there can't be accessed anymore. So it's kind of weird. You could put a file in there, you mount a file system on top of that directory, and you can't access that file anymore until you unmount the file system. Now swap is a special type of file system. And in fact, there's two ways to do swap in Linux. You can create a disk file actually and do swapping to a disk-based file that's actually on your regular ext3 file system, or you can create a partition and actually use a raw partition for swapping data. You know, swap is of course used if you're running low on RAM. Your system takes whatever's in RAM and puts it off onto the swap file system. Now new swap partitions can be created, and they're turned on and off with the swap on program and the swap off program. To see if you need additional swap space, use the free command. That'll show you how much RAM is free and help you determine if you need additional swap space. Swap is created with the make swap command. That's what you use to make a swap partition. Now let's talk about RAID. RAID stands for Redundant Array of Inexpensive Disks. RAID is when the operating system or a hardware controller is creating multiple pieces of the same data for redundancy or for performance. There are different levels of RAID. For instance, RAID 1 is just a mirrored pair. You have, let's say, 2 disk drives. It could actually be more, but those 2 disk drives are in sync with each other, and everything that's written to one is written to the other. There are many other types of RAID. But RAID can be configured at installation time, but it's not for the new Linux user. You can actually create additional RAID partitions after boot time if you like. Now you can create RAID file systems with the make RAID command or with the GUI Logical Volume Manager. Networked file systems must be mounted as well using the mount command. So we're off of the RAID topic and we're talking now about networked file systems. Networked file systems you can think of as shared drives. So like in Windows, you have a server, you share off a drive on that, you take a PC, you connect to the shared drive over the network. Let's call that a networked file system. Now you must mount these in Linux. Just like you map a drive in Windows, you have to mount these file systems. And you use the mount command to do that. And that's for usually network file systems, or NFS, network file systems. Now what's gained a lot of popularity is SMB or Samba file systems. SMB is of course the Windows file sharing protocol, and Samba is the program that runs on Linux that shares Windows files. So, but besides having a Samba server on your Linux system so you can share your files to Windows clients, there's also a Samba client on the Linux system. So if you have a Windows server, you want to be able to read those Windows files from the Linux client. You can do that. You can do that with the Samba client on the Linux server. Now to do this, you use the SMB mount command to actually mount a Samba file system. CD-ROM drives, by the way, must also be mounted. They're usually mounted on the /mnt or the /media directories with a mount command that looks like this. Mount -T for type, and the type of CD is ISO 9660. -R for read-only, because it's a CD-ROM, it's read-only. And then the device, which is /dev/CD-ROM, that's your default CD-ROM drive. And then /media is just our mount point. Now we could create any mount point with any name and mount this CD-ROM on top of it. You can, of course, burn CDs and DVDs in Linux. There are a number of programs available to do this. With that, let's move on to our scenario. Now, our scenario at the Big Sky Fishing Company is that you need to add an additional file system for the company ordering application. It requires a dedicated 500 megabyte file system. To do this, add the new /fishing file system to your Linux server. You will, of course, have to create a new partition so that you can create a file system so that you can mount the fishing file system on your Linux server. So let's give it a try. So we're over here on our Linux server, and what I've done is I've put a new disk on this server. So it's the equivalent of taking a new physical disk and installing it in your computer. I haven't done anything with the operating system because that's what we're about to do now. Because this is a virtual server and it's running inside my Windows system using this VMware application, I'm able to, with a few clicks of the mouse, create a new hard drive for this system. So it just took up a new disk file on my Windows partition, but it's actually in Linux. To Linux, it's like a new disk. So, of course, this is just like if I took a PC and I physically installed a new 500 megabyte disk on that PC. That's what I've just done. And then I booted the operating system, and that's the point we're at right now. So pretend that we just installed a new physical hard drive on your server, and now we're going to configure the operating system for that hard drive. So to do that, I'm going to type fdisk/dev/sdb. That's the name of the new disk. We said any SCSI disk is /dev/sd for SCSI disk, and then a letter. So the first letter was A, and that's our primary disk. The second letter is B, and that's the new disk that we just added. And when the system boots, you would have seen that this disk was found. So I'm going to press enter there, and this is fdisk. It's not very friendly, but it does have help if you press M. So let's press M, and you can see the different options here. So the first one that I see that's interesting is D, to delete a partition, N, to add a new partition, P, to print the partition table. This is like listing the partitions. Q, to quit without saving, and W, to quit and save. So it's very important you do a W when you're done making changes, not a Q if you want to save those changes. So let's do a P. So we printed out the partition table. This shows us that we're working with dev SDB, and it's 536 megabytes, so about 500 megs, half a gig. Right now it doesn't have any partitions on it. That's what you would see down here, no partitions. So I'm going to press N to add a new partition. We're going to make this a primary partition because it's the first partition on the new disk. I'm going to say 1 for partition number. The first cylinder, it defaults to 1. I'm going to take the default by pressing enter. The last cylinder, it defaults to 512. I'm going to take the default again and press enter. And it just created our partition. Now it didn't tell you that really, but it did. However, it didn't actually go out and modify the disk. It's created in fdisk, but it won't be saved until you press W to write and quit. So I'm going to press W, and now it's actually modifying the partition table. So that's done. So if we type fdisk -l/dev/sdb, you can see here's our new partition. dev sdb1. That's the partition number 1. So we have our new partition. Now we need to do the equivalent of formatting it. What you would do in Windows, you would format it. Well, in Linux we use the mkfs, or make file system command. This is going to essentially format it. So I'm going to do dev sdb1. I have to specify the partition that I want to format. And I'm just going to take the defaults here, the default file system type and everything. Press enter. And it goes through here and it formats the partition. And that's it. Pretty fast. So it formatted our partition. Now we need to create a directory to mount the partition. So if I do cd / and go to the root directory, I'm going to make a directory here called phishing. So I made a directory. Now I need to mount my new file system on that directory. So I'm mounting my partition, or file system if you want to call it, on this mount point here. This is our mount point /phishing. So that's it, it's mounted. So if I do a mount just by itself, it tells me all the mounted file systems. You can see here the last one is SDB1 on phishing, type ext2, and it's a read-write file system. Now if I cat etc fs tab, this is a list of all the file systems that would be mounted at boot. It's not on there right now. Our phishing file system isn't on there because we didn't modify this. If we want it mounted at boot, we're going to have to modify this. If I cat etc tab, the mount tab, it shows me all the mounted file systems. Notice that phishing is on here because it is mounted. Let's do a df. If I do a df command, this shows me all the file systems and their utilization, how much of the disk is used and how much is available. This is a very important command for a system administrator to know, the df command. So you can see here, here's the phishing file system. It's 1% used, has 479 megabytes available, that's what that is. It's a total of 507 megabytes, and its partition is SDB1. So we have our phishing file system mounted. We did what our scenario required, but now let's go out and explore a few other utilities. I'm going to clear the screen. And another utility I want to show you is called sfdisk. So this is like sfdisk. If I press enter, well, let's try that again and pipe that to more. Okay, sfdisk is a Linux utility for disk partitioning. So this is a lot like fdisk, but to me, at least the menu is a little bit more friendly. Yeah, it has more options, but it's also a little bit more verbose. So that's another utility. Another one is parted. This is a command line program. I've never used this program myself. I've always used fdisk, but I read the benefit of parted is that it supports large partitions in Linux. So it gives this parted command prompt here. If I do a question mark, it has its own little set of commands. I can select a device, dev sdb, and then I can print the partition table. So there's the partition we created, 537 megabytes it says. So the command menu here looks similar to fdisk. So that's parted. I'm going to type Q to quit. Another one I want to show you is the Fedora Logical Volume Manager. If you go to System, Administration, and Logical Volume Management, this is also called System-config-LVM. So it's a graphical tool. Now unfortunately it's meant to run on a display with larger resolution, so I can't see this section over here. That's okay. We don't need that section. We're just going to look at it for just a second. So it shows you the two different disks that we have on our system, logical view and physical view. Oh, I'm sorry, these are our volume groups, not our disks. These are our volume groups. You can see over here we're in the volume group section. If I click here on volume group 0 physical view, shows this disk, dev SDA, partition 2. Here's our logical volume, logical view down here. Here's our uninitialized entries. So I just wanted to show you that this program is here, that it exists, and it can be used to do a number of disk volume group functions. So let's close this out, because I have more utilities to show you. The next two I went and I installed by going to Applications, Add, Remove Software. I installed these two utilities here, parted, or gparted and qtparted. These are on the Fedora installation media. They're very nice disk utilities. In fact, I would recommend using one of these two utilities whenever you go to partition disk from now on. I mean, for the Linux Plus exam, it's very important to know fdisk and makefs and mount and etc fstab and all those different things. But for every day-to-day use, for ease of use, man, I would go and use one of these. So let's check out gparted. So very easy to use graphical utility. I can select my disk over here, SDB, 512 megabytes. The mount point is fishing. I can if I go to file systems here, it shows me the benefits of all the different file system types. So FAT32 can create, grow, shrink, move, and copy. JFS can only create. All these different things it can do. Partitions. There's no disk space right now, but you can create, delete, resize, copy, format partitions, mount, unmount, label disks. So it's a very nice utility. I would highly recommend gparted. And let's go look at the other one, qtparted. If we select our partition here, shows you the use space, 27 megabytes. That's really just for the partition table. I haven't even put any files on there. But it's 511 megabytes. Shows you the status. If I click on SDA, here's the primary partitions for this server. If I go up to disk, I can do configuration here. That's configuration for the program. Operations, I can format, create, delete, set active. Tells you information about these file systems. Very nice program, qtparted. And then there's just two other things I want to show you. One is FSCK, file system check. This is to fix corruption on disk. If I press enter, it says it's going to run a file system check on our mounted file system. May cause severe damage. Do you want to continue? We'll say no. Then it says it's going to do this. Basically what it's doing right now is it's going through etc fstab for every mounted file system, or every file system in there, and it's trying to run a check on that. I'm just going to say no. And let's do man FSCK. So you can see FSCK, its purpose is to check and repair a Linux file system. So you can specify which file system you want. Again, they say you should unmount the file system before you check it. And we won't go into that. It's just important that you know what the purpose of FSCK is. And then finally, let's go into dev, cd/dev. And I'm going to do an ls-l, pipe that to more. And these are all the devices on our system. CD-ROM is a device. It's actually a link to HDC. Here's disk partitions. Here's DVDs. Here's the different sizes of floppy drives. Pretty interesting. We talked about that in our slides. And notice these are block devices. Anything having to do with a disk is a block device. RAM, everything in Linux is a device. TTYs, here's our SDA1, SDA2 disks, TTYs, volume group, and there's even subdirectories here. But you get the point. This whole directory, by the way, is created when the system boots. So it goes out and it finds these devices and it creates these devices in dev. Now some of them are created like no matter what, like all these TTYs. We really don't have all these TTYs on the back of this system, but it creates them nonetheless. Other things like disk, it only creates if it actually has that disk. So that's what dev is. Now let's go back to our slides. So we were able to create the additional /phishing file system, 500 megabytes. We added it to our server. One thing we didn't do is put it in etc/fs tab so that it would be there every time the system booted. That's an important thing to do. But just so you know, right now if we rebooted the system, we would have to go in and just remount the file system. We wouldn't have to recreate it and do mkfs again. We would just have to simply mount it with that one command. So we successfully created our phishing file system. Let's go to our next slide. And we've come to the conclusion. So in conclusion, in this video we learned about Linux file systems. We learned what a file system is. We learned what a partition is, how you create a partition on a disk, and then you create a file system on that disk, and then you mount the file system. And file systems are mounted on mount points, which are really just directories. The mount command will show you what file systems are mounted at the time. The etc/fs tab tells the operating system what file systems to mount when it boots. The etc/m tab shows tells you what file systems are mounted right then. The dev directory is where all the devices are stored. And then we learned about a number of different disk partition utilities. We used fdisk, we saw sfdisk, we looked at parted, the Fedora Logical Volume Manager, the gparted utility, and the qtparted utility. And finally we saw the fsck program that's used to check your file systems for corruption. So with that, we've come to the end of video number 10. Thank you very much.